Okay, so this is my first in 4 videos about time value of money. I'm going to talk first about future values because I think they're one of the easier ones to understand and grasp to begin with. So this is a formula for future value. I got present value times 1 plus the interest rate over n, which is the number of compounds per year. So it's the annual interest rate over the number of compounds per year, raised to the power of compounds per year times the number of years. Okay, so for example, let's do the manual calculation first. So I have put in some data here. I've got $1,000 as a present value. If I invest $1,000 for 7 years at a rate of 10% compounded annually, I want to know what the value is going to be after 7 years. So how would I figure that out? Well, the kind of manual calculation method that we can do that I think probably most people understand is if I start with $1,000, if it grows at a rate of 10%, I can simply multiply that $1,000 times 1.1, and that would give me how much it is after 1 year. I can do the same thing again, multiply 1,100 by 1.1, multiply 1,210 by 1.1, and so on and so forth, all the way down till the end of 7 years to get the value as 1948.72. So the value of my $1,000 compounded annually at a rate of 10% at the end of 7 years, it's going to be $1,948.72. Now, I can also put that into a formula form instead to make it easier and to not have any typos here. I should be able to copy and paste something here. So the manual formula calculation would be $1,000 times 1 plus interest, 0.1 over 1, my n, raised to the power of 1 times 7. Will give me the same thing. So not having to go through all these steps of doing 1.1 years. I can also build this so that it calculates this for me instead. So if I build this with references instead of with numbers, so that this becomes effectively a future value calculator, I could say equals A14, that's my $1,000, times, it's my present value, so times 1, got a 1 in there, plus interest, 10%, it's A15 divided by A22, raised to the power of A22, which is n, times t, which is A17. And it should give me the exact same amount. Now, there's also an Excel function that will do this, which is probably the simplest overall method if you understand how to use it. And that function is called future value. So I hit future value and I go to my function bar here. First thing it asks me for is the rate, but notice that it says is the rate per period. For example, use 6 divided by 4 if the quarterly payments are if it's 6% APR. So if it's quarterly compounded, then I'm going to need to use the divided number. So effectively what that means is that I need to take this number divided by the compounds per year. Now in this case, obviously it's going to be 10%, but that is effectively in my formula, this number right here is my I divided by n. Okay, that's this part of the formula. The number of periods. The number of periods is my n times my t. That's what I've raised my power to. So in this case, that would be compounds per year times the number of years. And I do it this way because while we're doing a simple version now of only a single compound per year, I could have multiple compounds per year. I could have it monthly, could have it quarterly, could have it semi-annually like most bonds. So I want to make sure and leave this flexible so that if I change any of those numbers that it can calculate this for me anyways. Payment, that's something that has to do with regular payments like annuities. We're not dealing with that yet. So I'm going to reference this payment here, but it's just going to be 0. Present value, that's my PV number here, that's my 1,000. And type, we are going to, oops. Sorry, just give me a second to review this. So rate I got I divided by n, number of periods I have, n times t, payment is 0, present value is 1,000, And this has to do with whether it's an annuity or an annuity due. In this case, I'm going to make it just an ordinary annuity. So at the end of the period, so that would be a 0, or you can omit it and it automatically is a 0. And you'll see that it returns the same amount. Now notice this is negative. That's because the future value and present value function always assume that we're talking about cash flows. So it will always reverse the sign. So if this number is positive, this number is always going to end up negative. I can show you that's the case because if I change this, you'll see that the Excel function now comes out positive because this is a cash outflow and this is a cash inflow, which that's what this actually is. I'm depositing or investing $1,000. That's cash coming out of my pocket, and 1948 is what I'm receiving back. So that would be the cash inflow. So this is more technically correct. It'll always come out the opposite direction of whatever your input is for that reason. So that, in a nutshell, is how future values work and how the future value function in Excel works.